Okay, so Leetcode practice time. So in this videos, there are two goals. The first one is to see how to solve this problem, and we are going to do some coding work. And the second one is to see how to behave during interview. Suppose this is a given problem in a real interview. So let's get started. So remember, the first step is always to try to understand the problem, and if there is anything unclear to you, please bring up the questions, and also think about some edge cases at the very beginning. So let's take a look at this question. Shortest distance from all the buildings. So you want to build a house on an empty land which reaches all buildings in the shortest amount of the distance. And you can only move up, down, left, and right. You're given a 2D grid of values 0, 1, 2, where each 0 marks an empty land which you can pass by freely, and each one marks a building which you cannot pass through. Number 2 marks an obstacle which you cannot pass through. Okay, so example like this. So given the 3 buildings at 0, 0, 0, 4, and 2, 2, and an obstacle at 0, 2, okay, and the point at 1, 2 is an ideal empty land to build a house, as the total travel distance is 3 plus 3 plus 1 equal to 7. Okay, so if we build a building at here, then the distance to this one is 1, 2, 3. This is okay, and the distance from this point to this point is 3, and the distance between the 2 points is 1. All right. So some notes. There are at least one building. Okay. So definitely a good question to bring up. If there is any, there won't be any building at all. So for this question, at least one building. If it is not possible to build such house according to the about rule, return the -1. Yeah, so it is possible. So for example, there is the obstacle, like everything is obstacle, then there is no place for you to build any building. So let's take a look at this one. And also, for example, if there is a building here, and there is an obstacle here, here, and here, then it's not possible to build a house somewhere, because there are 2 buildings and there is an obstacle that blocks the 2 buildings entirely. So that won't be possible. So let's see how to solve this problem. So I think we are pretty much good understanding the problem. So let's think about the solution. So how to solve this problem? So I would say, yeah, I think one solution I can think about is starting from each of the building. You do BFS. You do BFS on the interland. So you can generate a 2D matrix which is the same size of this piece of land, and you do BFS on top of, for example, this building. Then you're going to generate the distance from all the points to this building. Yeah, so that's one thing I can think about. And yeah, so for each of the building, you do BFS, and then you generate, for example, let's say there are n buildings. You have n matrices to store the shortest distance from each point to the corresponding building, and you add up all the matrices together. Of course, you don't need to have all the n matrices at the same time, but it's something like that. You do the BFS each round. You generated shortest distance matrix to the corresponding building, and you just do a for loop, adding them all together. So you don't need to create matrices all together, but you create one at a time. I think that should be a possible solution for this one. I would say, suppose the size of the size of the len, let's say the 2D matrix is n by n, and let's say there are x buildings, then we will need to extend from each building, do BFS on top of it, and each BFS is going to take m by n. So it's gonna be O, m, and x. So this is the runtime for this solution. Okay, so let's see if there is any other possible solution for us to do. If so if it is, yeah, so if we if we or if we do BFS on top of all the empty land, generate the distance to all the buildings, and similarly, so like it's a similar solution. Like either you do BFS on top of each building, or you do BFS on top of each empty land. So other than that, because we need to at least know that the shortest distance between a piece of land and one building. So I think we should at least, so I think from this perspective, I think that would be a good, I think this should be like a most efficient way to solve this problem, because we need to at least know the shortest distance from each piece of the land to the different building. Otherwise, we are going to miss some we are going to miss some piece of information. So if that is the case, I think that should be the best one regarding the runtime. So let's get started and do some coding work on top of this. So after you have an agreement with your interviewer about the solution itself, try to do some coding work. So here you care about the correctness of the code, readability of the code, and also the speed. So let's do this. Sure. So okay. Okay, so I think one thing I can think about, if there's no land to build a house, that could be an edge case, but I'm thinking if we definitely need to do that. Let's see. So we can have a check at the very beginning to see if there is any empty land for us to build a house on top of it. There could be a function. Sure. So first of all, if let's see, if not available, so this is definitely a helper function. If it's not available, then we are going to return -1. So you're going to define a private function here, helper function here. Let's call it available. So available. Okay, so grade. So and also we may need to check the size of the grade to see if it is empty. So if let's see, so int row is equal to grade.length. It says that at least one building, so it means that the grade shouldn't be empty. But so that's the case. So if that's the case, we don't need to check if it is empty. So let's see, int I is equal to 0, I smaller than the row, and plus plus I. Int j is equal to 0, j is smaller than the column, and plus plus j. So if column, grade ij is equal to a 0, then return the true. Otherwise, you just return false. So it's for sure that there is some available empty land for us to build a house on top of it. So then we are going to do some DFS on top of each of the buildings. So I is equal to 0, I smaller than grade dot length plus plus I. J is equal to 0, j is smaller than grade dot length plus plus j. So at this time we need to define like a shortest distance thing. So let's say the shortest distance is equal to new int grade dot length 0 dot length. Okay, so this one is going to new the row and the column. Yeah. Okay, this is the row, this is a column. All right. So yeah, that's it, and that's pretty much most of the things we need. And we are going to get a helper function here. So int 0, 0 shortest distance from ij. So shortest distance maybe pose. Let's say it is equal to the get shortest distance. This one would be, let's say this one, we are going to have the grade pass into it, and we are going to have the I and j for pass into it. So this is a helper function which we are going to implement later on. So shortest distance. So the shortest distance is going to return a matrix similar size, which is the same size as the input grade. And suppose if it is going to return, so if the corresponding position has a value as max integer, then it means that that piece of land is not available. Let's see, or do I need to make that thing? If let's see if we need to definitely have a number to represent if the piece of the corresponding position is available to be reached out from ij. So let's see. All right, so let's see. So and then we are going to have the add up them together. So let's see how to do that. So we are going to do add distance. So this is another helper function. So you're going to add the shortest distance, add the short distance pose on top of the shortest distance, and then finally you're going to say, all right, so int I, and finally you're going to say, okay, we have learned everything. Plus plus I 0, j is smaller than call, and the plus plus j. So the shortest distance, let's say finally int shortest distance. So shortest distance, how to say that? It's shortest distance, let's say, yeah, because we already have the shortest distance. Let's say shortest distances. It's the shortest distances. Okay, it's the shortest distance is equal to integer dot max value. If shortest distance if its shortest distance is ij is equal to a let's say if it is equal to, if it's equal to, let's see, not equal to, then yeah, so if shortest distance, let's just say shortest distance is equal to max dot min shortest distance and shortest distances I and j. And then finally we return the shortest distance. Okay. Yeah, so we have two helper functions to implement now, which is the get shortest distance using BFS to extend from one position. So this one, it is going to return this, and the shortest distance, get shortest distance. Okay, shortest distance. Okay, get shortest distance. Yeah, this is a grade, and this is I, and this is the j. Okay. Yeah. So first of all, we have the int row as equal to 0. Sorry, grade dot length column is equal to grade 0 dot length, and yeah. So first of all, we need to have the queue. But so what do we need to contain in the queue? So let's see. So let's see. First of all, let's have a temporary matrix, which is let's define it as shortest distance as new int. So this means the shortest distance from ij to all the other places. So this is shortest distance row, and this is a column. So we are going to initialize each of the number as -1 plus I is smaller than row, and plus I, and j is equal to 0, j smaller than column, and plus j, and then shortest distances I and j is equal to -1. Then we need to define the queue. So what should we store in the queue? So let's say we define a class of the pose. Let's see, we have several different things, which is the row. Okay, this is int public int column, and also how yeah, I think that's it. So you have a constructor for it, which is int row and int column. This dot row is equal to row, this dot column is equal to column. All right, so we are going to have, first of all, have a queue of the post, and let's say this queue is new linked list. And first of all, we are going to push to add. I think it's add, right? Yes, it's add. So it's add a new post I and J into it. And then you're going to say, and we are going to say that let's see. So we are going to say, all right. So the shortest this tenses I and J as equal to 0, which means we have already visited this position, so we don't need to visit this position again. If it is -1, then it means that this position hasn't been visited actually. So you're going to say, well, the queue is not empty, is empty. So when well, it is not empty, then we are going to have the size as queue dot size, and yeah. So is there any? All right. So okay. So let's say if this is a post, not post. Let's say how to give it. Maybe just give it a k. K is equal to 0. K is smaller than the size, and plus plus k. So first of all, we are going to pop things from the queue dot pull. So this is a pose. Pose is equal to, we are going to push it out from the queue, and so we have the corresponding I and the corresponding column and row for it. Alright, so we have the I and J, the corresponding column for it. And we also need the distance actually. So public int distance. So int distance is not distance equal to distance. Yeah, so this one we are going to put I, J, and 0 into it. Alright. So at this time I actually don't need to have it. Yeah. So let's see. If let's see, if it is an obstacle, what should we do? So if the grade pose.row row and pose.column, if it is equal to a no, so if it's equal to a 2, so if this one is equal to a 2, then then actually this one is inaccessible. So if it is inaccessible, so we are just going to continue. So if it is equal to a 1, if it is equal to a 1 or 2, pose dot row, pose dot column. If it's equal to a 1 or 2, then it means it is not accessible actually. So if it is equal to a, but if it's, yeah, so if it is equal to a 1 or 2, then it means it's not accessible. Then we simply just continue it. but the thing is, we start with somewhere. Okay, so if yeah, so how to do this? If it's equal to R2 and it's not that position, means okay, so let's see. So if it is equal to end, it's not pose.row. Pose.row is equal to I, or pose.column not equal to J. I mean, it's not the identical position, so it's not. It's actually, we could do it like this, which is more obvious. If it's not the starting position, and it's not the starting position, and it's a 1 or 2, then we simply just continue it. Alright, so, and also if grade, so if it is, if we have already visited this, if the shortest distance, pose.row and pose.column is equal to a is not equal to -1, then it has been visited already. Otherwise, what we are going to do is we are going to set grade I and j as equal to pose.distance pose.distance. Not this one. So it is shortest distance ij is equal to pose.distance, and we are going to push q dot if pose.row is larger than 0, then we are going to q dot add a new pose pose -1 pose dot row -1, and this is the pose dot row -1 and pose dot column and pose dot distance +1, and if pose dot column is larger than 0, then q dot add a new pose pose dot row and pose dot column -1 pose dot distance +1. Right, so if pose dot row is smaller or then what is that, the row -1, then we are going to say q dot add a new pose this is pose dot row +1 and the pose dot column and the pose dot distance +1. Alright, so if pose dot column is smaller than the column -1, then q dot add the new pose so this is pose dot row pose row, and this is pose dot column +1, and this is pose dot distance +1. Alright, so that's the thing, and finally, when the BFS is done, we just return the shortest distances of it, And there is another helper function, which is the add. So we are going to, actually we need to have the grade information as well. So grade information, okay. So void public void add distance. Yeah, so this is the grade, and this is the shortest distances, and this is shortest this house. Okay, so shortest. Okay. All right. So how to add them up? So if okay, so first of all, still we are going to get row and column is equal to grade dot length, and column is equal to grade dot length, and we are going to iterate through everything of them. 0 I is smaller than the I is equal to 0 as smaller than what is that? Okay, so I is equal to 0 as smaller than the row plus I, and int j is equal to 0, and j is smaller than the column, and plus j. Alright, so it's the shortest distance. Okay, I would say if if grade ij is equal to a so if grade ij is equal to 1, or the grade ij is equal to 2, then it is a piece of land that is not accessible. So we will say shortest distance is I and j as equal to integer dot max value. Okay, equal to integer max value. If yes, then -1, otherwise the shortest distance. Alright, so yeah, so max value. So otherwise it is, we just simply continue. Otherwise it's an empty land. We will see if the shortest distance pose, if this one is a -1, then actually it means that the corresponding grade is not accessible from one building. So we are going to say, alright, the shortest distance ij is equal to the max integer value again. So continue. So otherwise it means it's a piece of land and it's accessible. Then we are going to say, alright, it's the shortest distance says ij plus equal to shortest distance, so I and j, and then we don't need to return anything, so we are going to modify this in place. Alright, so let's see, I think that's pretty much it. So that's the next part is about testing. So remember that when you're done with coding, it's not done. You still need to do some testing. So the first step is about doing some sanity check to check the logic of this piece of code. Better to go through an example explaining how this piece of code is going to work, and at the same time explain, so it's a time for you to do some communication work. And after that, if you're comfortable, then to set up some different test cases to increase the test coverage. So let's see. So for this one, get shortest distance, which is this. So at the very beginning, we see if it is available. Available means if there is any empty land. So if yes, then we return true. Otherwise, we just finally return false. So if it's not available, we just return -1. Otherwise, we get the column number of the grade and the row number and the column number of the grade. And then we initialize the shortest distance. Every piece is gonna be 0. And then for each of the thing, so it's actually we need an if branch. So if it is empty, then if it is if grade ij is equal to 1. So if it is a building, then we need to compute it. We need to do BFS on top of it. We don't do DFS on everything. So if it is a building, then we just get the shortest distance from all the other position to the corresponding building, and then add them up, add the distance to the current shortest distance matrix. Okay, yeah. So and then finally we have we just get the shortest distance as a mean among all the shortest distances. If the shortest distance didn't change, then we turn -1. Otherwise, we return shortest distance. Okay, seems to be fine. And then let's see the implementation of the shortest distance. Let's take an example for this one. So let's start from this position. So for this one, at the very beginning, we are visiting 0, 0, and we initialize the shortest distance, everything as -1. And then we put 0, 0 and distance as 0, which is the position into the queue. And if queue is not, well, it's not empty, then we have the size of the queue, then we iterate through the current size of the queue, and we pull it. Every time you just pull one node, one position from the queue, and we see that, okay, alright, so the first one we pop up is this. So we see that, alright, so it is the position of ij, so this one is going to return false. So it's not, this one is going to return false, so this if branch is not going to be workable. And then we see that the shortest distance so it is equal to -1. So we are going to see the shortest distance ij is equal to, so this one is set to be 0. So otherwise, let's see, if the pose so if the pose dot row is larger than 0, so if it's larger than 0, if it's not larger than 0, and it's not larger than column, both column and row are 0, 0. So but we can extend to the right and extend to the bottom. So we are going to extend to the right, we are going to extend to the bottom, and this one we are going to extend to the right, and with a distance +1. Next time we are going to pop this node and this node. So this is going to set as 1, this is going to set as 1. Alright, so it seems like so the function of it, it means we are going to, for each building, so let's say we are going to, for this building, we are going to compute the distance from the original point to every other point. So if it is an original point, then we are going to set as 0, and otherwise, if it is a building or it is a blocker, then we are going to keep them as -1. And if the piece of land is, if the corresponding empty land is not available, then it's staying at -1. So that's essentially what this is about. Sure, so let's see some other things. So add distance. Let's see the add distance. So suppose I have the shortest distance from the pose and the grade. So I is equal to 0. Okay, so we trace every element. So if the element is 1 or 2, then it's not, we are not going to build a house on top of it. So we are going to set as max value. And for int, so if it is ij, so if it is -1, then it means that the land is not, at least not accessible from one building. So we are going to set the shortest distance as max value as well. And then shortest distance ij, if it's a empty land and is accessible to these buildings, then we are going to plus equal to the shortest distance. Okay, so I think it looks mostly good. Let's give it a shot. Alright, so 47. Let's see what is 47. Alright, so it's I and j thing. So this is let's say pose I and pose j. And pose j. Sure. So this is I and j. So we actually I think we can just say arranging I and arranging j. Okay. So this one is going to be arranging I and arranging j. So this one similarly origin I, and this is origin j. So let's see. Yep. Let's give it another shot. So this one 65. This is the shortest distance. So actually it should be this one. Now the I and j. So it's a wrong answer. So output is 0, and we expect to be 7. How? Why the 7 and 0 stuff? So let's take a look. So if we have 1 0 2 0 1, which is this one. So going to be for sure to be. Is it possible that we don't really in BFS we don't extend to some certain position? So let's see. So so let's see. Get shortest distance. I really want to see this one, which is the shortest distance. I is equal to 0. I is smaller than the row and the column. So I would like to print out the matrix. So j is equal to 0. J is smaller than the column plus the j. So if alright, so we are going to just print it out. So system.out.print this is the shortest distance is ij. I and j, and yeah, so we are going to do this plus then we are going to say system.out.print line. Alright, so now we system.out.line I plus j. Yes. Let's see. So if I run the code, which is arranging I, arranging j, arranging I, arranging j. Yep. So it says okay. So this one we have the standard output. This one we have it as 1, 1, 2, and 2, 3, which looks fine. And for this one we have the 0. Okay, so it seems to be 2, 3. Okay, so it is 0, 2. Okay, 2, 2. This is 3, 3. Okay, this seems to be, yeah. So it seems to be fine actually. So this one, the BFS seems to be fine, and let's see the shortest distance. So I would like to see the shortest distance as well. This is called let's say this is BFS, and this is the add. Say this is add. Okay, so let's see. Take a look. This is not arranging I, arranging j, so this would be just simply add. Shortest distances. We are not going to return things here. Run the code. So BFS, it seems to be right, and then now we have. Let's see. So it's the shortest. After adding, why do I? Oh, okay. So actually, I have a typo here, which is grade 0 lens. Alright, so okay, so I have a typo here. So this is a typo. So I'm going to remove all the debugging here, the debugging stuff here. Alright, so let's do a summation again. Okay, so it's wrong answer. Why? So we have 0, 1, 2. Let me. So this is the wrong answer. Let's see why. So it's 0, 2, 1, 1, 0, 2, and 0, 1, 0. So definitely, yeah. So definitely, it's something unavailable. And why it is returning this something like this weird. It's really just awkward. Let's see, it's add a distance. If add distance is going to get us something correct. So first of all, we should be able to. So if it is, that means it seems like there's something overflow. It seems to be something overflow, but I'm not sure which part is actually being overflowed. So let's see. Let's see from this input case, 0, 1, minus 1, 5. This, okay. Seems like adding all it up is just fine. And then BFS on top of it, everything keeps the same. Then BFS on top of it, everything seems okay. So it seems like I'm adding the integer max value on top of something and caused some overflow. So why? If grade, okay, so if it is a something equal to a 1, and then we return it as 1, So task case. Alright, so let's see, I give it this task case. Let me just recover all the things. Let me just run this task case and see what is the output. Alright, so it is -1, -1, 0, and everything is unaccessible. Everything, so it is everything to be unaccessible. Oh, okay, so if the original thing is unaccessible, then it's unaccessible. So definitely some bug within the code. So if it is max integer dot max value, then we just simply continue it. Yeah, so at this time I think we should be good. Let's do a submission. Okay, so time limit. So it seems like we hit the time limit. Let me just remove everything unusable here. The debug output. So I would just say submit it. Alright, so yeah, it's a debug output that wastes our time. But glad we finally get it. Yeah, so that's pretty much the solution. So remember the task case setup. Always set up some task cases like this, which is pretty normal, and also set up something that has some that it's going to return -1. Yeah, so that's it for this coding question. If you have any question about this coding puzzle, about a solution, please leave me some comments. And if you find this video pretty helpful, please give me a thumb up, and I'll see you next time. Thanks for watching.